One last practice problem, I promise. But I want to bring this up because it's pretty interesting. And it just goes along with the whole idea using data and math and science to either back up an argument or not. So don't judge until you've done the research. That's what I'm trying to tell you. Now, ever wonder if rechargeable batteries are worth it? The, Hey, this is the last example, I promise. I'm done beating your ear. Well, not really done beating your ear with math, but this is the last one for this series. So, do you ever wonder if rechargeable batteries are worth it? You go into a store and you see the upfront cost of $16.99 for four AAA batteries, and you're like, holy moly, really? $17 for four batteries when I could just buy four AAA batteries for $5.29. That's crazy. Well, that's going to potentially deter people away from buying this. So let's figure it out. How much money do I save per year by purchasing four AAA rechargeable batteries for $17 instead of constantly buying non-rechargeable AAA batteries? I did this. I collected data for a couple months, and on average, I would charge 12 AAA batteries per month. So at any time in this video, just hit pause, try it on your own, and then come back to me and see if you're doing it the way I am. The first thing that we need to do is we have to figure out how much money I'm spending if I didn't do the rechargeable battery route and bought four AAAs for $5.29, assuming that it's the same rate. And that rate is 12 AAA batteries per month. So let's start this. Write down first, before you write down what you know, go back to the question, and the question's asking you to put your answer in money per year. And those are what your units should be when you're finished with dimensional analysis. Start off with what you know. I know that the problem is stating that I buy 12 batteries per month. And I have to understand that dollars per year is the unit that I need to have left standing. So batteries a month are going to have to cancel each other out sometime, sooner or later. So it's 12 batteries per month, and now I need to calculate how many batteries per year that is. Well, I know that month goes on the numerator to cancel that month, and there are 12 months in 1 year. And I also know that those four AAA non-rechargeable batteries cost $5.29, but that's for four batteries. So that battery cancels out that battery. And when I do the math, well, before I even do it, I just want to point out that dollar sign and year are the only two units that are not canceled out, and that's what the question's asked me to put my answer in. Pretty good odds that I did this correctly. And when I multiply across the top, I get $190.44 per year. That's how much I save. But I can't really claim that that's how much I save until I figure out the payback period, right? I just got in math lecture 2, I talked about the payback period. Well, in order to figure out the payback period, remember it's the initial investment, which was $16.99, and we just calculated the savings per year at $190.44 per year. Put parentheses there if that helps you. And when you divide those two, you get an answer of 0.09 years. Like I mentioned in the second math lecture, that might be pretty hard to grasp. What is a 0.09 years? So let's convert that to months. Years has to go on the denominator to cancel that years out here. In 1 year, there are 12 months. So when I multiply across, and as I multiply, well, when I do, the answer is 0.09 times 12. And that gives me 1.08 months. That is the payback period of this product. So after, let's just say, well, let's just round down. After the first month, then I can claim that this is saving me money. I would say that has an excellent payback period. You need to invest in those. Amazing, by the way. But you always get the skeptics, well, you have to plug it into the wall and it uses energy, and how much money are you spending on that energy? Well, I'm one step ahead of you. Let's figure that out. Let's take a look at that wildly. So how much money is it going to cost me to charge these things? Well, if you look, how much money will I spend per year charging these batteries at a rate of 3 charges per month, charging at that rate of 5 hours per charge? I mean, you could see I purposely drain these batteries down to 0, so I know from 0 to 100% it takes 5 hours. And I plug this thing into a kilowatt device, and that tells me the power needed to charge these batteries. That's how I got this data. So let's just start off with what we know. We know that this is going to use 2.8 watts per charge. Don't forget the conversions up here. At 1,000 watts is equal to a kilowatt, and 8 cents is equal to a kilowatt hour. So if watts is up here in the numerator, let's put watts down here in the denominator so we can cancel that out. That must mean that 1,000 goes on the denominator and 1 kilowatt goes on the numerator. So again, we're going to keep going here with our dimensional analysis. And well, so 3 charges per month at all 3 at a rate of 15 hours per charge, 5 hours per charge. So 3 times 5 is 15 total hours of charging per month. So now that cancels that. And I think I have to keep going because it asked me to put my answer in money per year. So I need to have dollar signs per year is the only 2 units left standing. So I got to keep going here. Well, I know that months has to go in the numerator to cancel that month out. And there are 12 months in 1 year. And right up here, it tells me that the conversion rate is 8 cents per kilowatt hour. In a previous lecture, I told you that a kilowatt times an hour is a kilowatt hour, right? You remember that, I hope. So that kilowatt hour cancels out that hour and that kilowatt. And now the only units left are dollar signs in year. So as I do the math, 0.04 per year. That means that it's going to cost me 4 cents per year to charge my batteries. It's not even worth putting that into the problem. Like, take that out of the equation, man. It's negligible. Like, that is so, yeah. If someone says, well, you got to plug it into the wall, tell them to watch this lecture. And then maybe that entices them that maybe these are worth it. Now, to be honest and transparent, I didn't do any research that explains the upfront cost of these, like what's it costing the environment. So maybe you can do the research and figure that out for me. All right, I am done. I hope that you got these problems right. Now you know how to use dimensional analysis. Thanks so much. Bye-bye.